Hi, I am Anna, and I'm part of the AI community for some years now. And within the community, there's a joke that sounds like this. What's the difference between machine learning and AI? So, if it's written in Python, it must be machine learning. But if it's written in PowerPoint, it's most definitely AI. So, we wanted to leave aside for a while PowerPoint presentations and show you a quick demo, a proof of concept of our AI capabilities pertaining computer vision. So it goes around image and video processing with object identification, people's faces identification, postures, and actions as well. And this is a use case focused on health and safety in the workplace with focus on the manufacturing industry. Think about factories and the employees working in these factories or power plants and how they need to comply to specific regulations like personal protective equipment or danger zones. So we have thought of this web application based on the Workplace Health and Safety Guard, which incorporates an incident management platform. And as you can see, we have a pretty classic login page, and once you give in your username and password, this will bring you to the home page of the application. And for the home screen, we have thought of a helpful summary of the notifications and alerts that might have come up in the meantime. For example, danger zone violations. Within a factory or a power plant, there are specific areas which come with a high risk of incidents for the employees. These areas are normally marked with banners, quite visible banners, or highlighted with quite strong colors like red or orange, so that the employees would not trespass. But in case these are overseen for any kind of reason, we have thought of AI models which could automate the monitoring and as such prevent any kind of unwanted events in such contexts. PPE notifications. So this comes from personal protective equipment. Employees need to comply to specific standards. Also, in terms of equipment, if they have specific roles within the factory of or within the power plant, and they would need these equipment either to enter or to do their job within the factory. Imagine a camera placed at the entrance of the factory, and with this camera, we would be able to monitor or to scan actually the equipment of the employee and to specify whether the proper equipment is in place, like helmet, vest, or even goggles for some contexts. And in case this does not comply with the regulations, either we do not enable the entrance within the factory, or if this happens in the factory itself, we could send specific notifications or alerts. Posture alerts. Think about the danger zone violation. So in case of such zones being trespassed, and an incident is happening, like an employee is being injured or being hit by heavy machinery or a robotic arm, such a posture, fainting, or any kind of unnatural posture could be depicted through the surveillance system and the processing of the video footage by the AI model. So we could trigger afterwards, after determining the unnatural posture, specific actions like stopping the robotic arm in a timely fashion. Or we could also trigger alerts, notifications, urgent notifications on any kind of communication channels. And of course, for a duty manager or the management roles, the open incidents could be of interest in case they need to comply with specific audit purposes, or they need to take this into consideration for later on. For the dashboard part, we have thought of representing numbers in a meaningful way. So for the top danger zone incidents, we can categorize this by type, by risk zone, and by area, because in a factory we have different areas like injection area, compression molding, or transfer, and we can represent the number of incidents or the type of incidents on these specific areas, and also represent them in a timely fashion. So for a specific time frame, when and which kind of incidents were happening, and we can also see with specific representation their numbers increasing or decreasing. Also for personal protective equipment incidents, we would use the same format and represent these incidents also by type, whether we have such incidents happening on the helmet part or the goggles or vest compliance. And we can also monitor these kind of numbers in a representative manner, so that a shift manager in the end could take informative decisions. In the incident management part, you will see a bit in a few moments how we are automatically filling in this part with incidents, as we will map them to the AI models, which are predefined. Within a factory, we we have thought of a map and a way to map specific areas to specific zones of the factory. And for these zones, it is possible to enable one or more services available on the platform. For example, in the compression molding part, the personal protective equipment service is enabled also together with the danger zone monitoring. But in the case of the transfer zone, we just have the personal protective equipment, as we do not have any kind of danger zones. So such models would not be of any use in this case. Of course, we also have a part of reporting, because the auditing part might be quite relevant for some roles using this platform. And for the sake of the demo, we just have two representative reports within the application. And I will show you right away within the incident management how we can also create or define such report for further documentation of specific cases. And I think the most interesting part is this smart CCTV section of the application, where we are able to, or we would have the possibility to add cameras. So we would have specific video footages coming from CCTV cameras from specific areas of the factory that are being added in this part of the application. But for the sake of the demo, I will show you here some pre-processed videos of the AI models that we have thought of. And in this case, we are using public video from a subway. And we have used this video that we found on the internet in order to track specific individuals and to be able to demonstrate the tracking mechanism that we have defined within the AI modeling. You will see also a bit in a few minutes that this tracking mechanism is also used within other AI modeling scenarios in order to track, for example, the path that an employee is walking through in case we need to depict danger zone violations. And in case you are working with AI modeling for a while, you would know that also a challenge would be to depict or track individuals within a group, which is done also here. The processing of such video footage is triggering notifications within the incident manager, and you would be able to see the notification also on this page, which will bring us to the incident management part. And here we would have more information regarding this incident by itself, also together with specific parameters like the incident date, the category, as we will have different categories for different type of incidents, the state of the incident, whether this is new, it can be reopened, whether closed, or closed in case we have found a resolution for this case. We can also set a lower priority or a higher priority depending on the context. And we also are able to assign it to a specific person or a role within the company. Going back to the smart CCTV, I will just delete this video footage because it would trigger another processing of the incident. And I will further show you a laboratory cam fall. And in this case, you see here one individual entering the laboratory, of course, followed by his colleagues afterwards. But the main reason is him being tracked and then the falling being identified as an unnatural posture. And we see also here we have triggered an event, a notification of an incident, which leads us to the incident manager. And here we have more information to the fall category, the fall incident that was just registered. And you see here, we also have the tracking mechanism being used, as it's quite important to know on which was the path that the employee was stepping through. And of course, this is the area where the incident happened, and in this case, the falling. And in order to make things a bit more complicated, this time I will show you the tracking mechanism combined with the falling incident and also with the danger zone violation. We are using pretty much the same scenario, but this, as you see, is from a different camera angle from the same laboratory. And also in this case, we have highlighted this orange part of the scenery as being a danger zone. So once this is trespassed by the employee, also an incident for danger zone violation will be triggered. So in this case, once I close this, we see we have this time two notifications, two incidents. And this time, these incidents are for the same video footage, and we have a fall incident and a danger zone incident. And for the danger zone, we see the tracking of a specific individual employee or more employees in case we have more working in the same area. And of course, we also have the area in which the following incident happened. In case for any kind of documentation or reporting purposes, we need to have a specific documentation for these incidents. We are able to give some example, giving some details for the reporting part and save it as a report for later on. And you see here, report number 3 has been created in order to keep track of this. Another specific use case pertaining the personal protective equipment, we have used the wearing of masks case, which is, let's say, quite obvious also during these times, these pandemic times that we are going through. And we are using this public video, which monitors specific individuals, and we have processed this through the AI model of the wearing of masks check that we have defined. And you see individuals are being or faces are being checked once they come to a specific distance to the camera. And if they are wearing masks, we have a green box highlighting this. Or if we have an improper wearing of the mask, as the first face in the video, we have a red box highlighting this. In case of red boxes, here, of course, again, we trigger a notification for the specific video footage, which has the category of personal protective equipment. And of course, we can again give in some more details for the personal protective equipment case. And this is again for reporting and documentation purposes. So, taking a quite quick look at the incidents in the incident management part, we see the different categories that we have taken into consideration when defining the AI models, and of course the priorities, the different kind of priorities, which may be overwritten by editing the incident, as we have thought of the tracking mechanism first of being of low priority and of course high priority for the unnatural postures. These imply quite some risks for the employees. This was a short overview of our AI capabilities for a specific use case, the health and safety in the workplace for the manufacturing industry. So you saw computer vision skills with focus on image and video processing. You've seen also object identification, people's faces identification, posture, and actions as well. You might ask yourselves, how much does it take us to come up with a new AI model? So the answer is, it depends on data at hand, as data is the most critical starting point for any kind of AI solution development. But if we would think of a recipe, a general recipe, and if everything goes well and we successfully go through discovery phase, a feasibility phase, and through prototyping, let's say we could come up within 4 months with a prototype that would be later on integrated into your productive system. I hope it was useful and you got a glimpse of how we could help you set up AI and bring automation to your context and the field of interest. Hope to be hearing from you soon, and why not maybe start a collaboration with us. Thank you.